Thank you.
So, assuming then that we have a simple POJO, we want to write a movie site, and we have actors and we have movies. How then would you do to persist this into Neo4j using Spring Data Graph? Well, assuming you have this POJO that you see on screen, you add one annotation, @node entity, done. After this, Spring Data Graph will look at it. It will create a node for it once actor is instantiated. And whenever you change name here, for example, then it's going to be written to the property of that one node, to the name property of that one node. So super, super simple and straightforward. You can even add annotations like index to say that, hey, I want to be able to look up actors by this name. And we'll get back to that later on when we talk more about repositories. So incredibly straightforward. But what if your field is not a primitive type like strings are? Actually, more specifically, strings in the JVM aren't primitive types, but they're treated as such. But what if you have another node entity as your attribute? In this case, every actor might have a favorite movie. If you look into the graph, you have a movie that is represented by a node, in this case, the matrix. And you have an actor, in this case, it looks like it's Kevin Bacon. And the way Spring Data Graph is going to handle that is it's going to look at the field, it's going to figure out, hey, this is not a simple primitive type that I'm going to store as a property, but it's actually backed by another node. So let's create a relationship. It's going to create a relationship between the Kevin actor and the Matrix movie. Pretty straightforward. That's one-to-one in the graph, from one node to another node. What if you want to express one-to-many? So in this case, we want to have all the movies that a particular actor have acted in. So we add a set of movies. We add a method called actIn, where you can pass in a movie, and it's going to add to that set. And then we annotate that set, the movie set in this example, with an related to annotation. And we describe the type. actIn is the name of this relationship, particular relationship. And we also say what class or what POJO type Spring Data Graph should use to wrap the underlying node on the receiving end of the actIn relationships. In this case, they're movies, so we want them to be represented by the movie POJO. Pretty straightforward, I hope, so far. So then let's drill down and see what actually happens. Here we have 8 lines of code, and we're going to go through every line quickly and see how it's represented in the graph. And we have one caveat to this that I will talk more about later. There's actually an exception to this that has to do with lifecycle and detached entities. But setting aside that, what happens when you instantiate an actor, it's going to create a completely blank node. It only has an ID, but that's it for Brad. And then we execute the setName method on the actor. Spring Data Graph will intersect once we modify the name field. It's going to intersect and say, hey, this is actually backed by the graph. So let's write it down as a property on the graph. And that's what we do here. We create a new actor, Edward. We set the name of that actor. We create a movie, which is going to create a new node. We set another property called title of that. And then when we execute the actIn method, we're going to draw a relationship between Edward and Fight Club and between Brad and Fight Club. So pretty straightforward. Now, to get a little bit more advanced, let's try to do something fancy, which is what we call co-actors, which is similar to co-authors of a book. If you're a co-actor, that means that you've acted in the same movie together. That's something that you may not want to store in a separate list. You could do that, but then you sort of run into this whole problem where, once you add a new movie and you add actors to that, you need to update multiple lists. It would be really neat if we could figure that out dynamically. And that's when you see you have access to a method called find all by traversal in all node entities. That one is also available from the graph repository that we're going to look at later. You pass in the traversal description, which is very similar to what we looked at for the recommendations a while back. And what it does is that it traverses the acts in relationship. It goes 2 steps. The first step from a given actor, let's say Brad, is going to go to a movie. And the second step is going to go to all the actors in that movie. And that's going to be true for all the movies that Brad has acted in. And we're going to return that as an iterable of actors. And these are Brad Pitt's co-actors. And it's going to behave in this example as you would expect in terms of it won't return any duplicate nodes. It won't return Brad again. So he's not a co-actor with himself. It's not reflected. So that's really neat. Super simple to drop down and execute traversals. Now, to get even more fancy, what if we refactored the traversal code into a separate class, co-actors traversal? Then it turns out that you can annotate, you can create an iterable of actors called co-actors here, and you can annotate that with an @graph traversal. And then you can point it to a traversal builder, which is basically the code. I'm going to show you the code in a minute, but basically the exact same traversal code that we had on the previous slide. And we're going to tell it to return the nodes wrapped in actor instances. And we're done. And so we have a so-called dynamic or a virtual field, which is backed by traversal. So it's completely dynamic. And the co-actors traversal class looks the way you would expect. There's some ceremonial overhead, but basically it's just a traversal description, which is the same code as in the previous example. A very convenient way of declaring and working with traversals. Okay, so we've talked about fields that are primitive types, and we've talked about fields that are node entities. But it turns out that we actually support a couple of other nice things. We hook into Spring conversion, and you can write your own Spring conversion if you want to. But by default, we ship with conversion for enum and dates. So in this case, we have an actor with name, age, hair color, and nickname. And hair color is an enum, and that enum will be automatically serialized to the graph and then deserialized on the way up. Transient fields are handled the way you would expect, i.e. they're ignored. They're not persisted at all by Spring Data Graph. Remember how I said in my introduction that the key property of graph databases is first-class support for relationships. Relationships are objects that you can, they implement the same interface property container as nodes do. You can add nodes, you can properties to nodes, you can add properties to relationships. For example, in our movie domain, we might want to say that, hey, Brad, you acted in Fight Club, but we want to add some information to that. Specifically, we want to say the name of the role you had. And Brad Pitt, as we all know, was Tyler Durden in Fight Club. Then we just add it as a property to the relationship. So as you can see in the bottom of the screen, you have role, a role property with a value Tyler. And what we wanted, so that's cool on the graph database layer, but how do we want to work with that up in our domain layer? Well, actually what we want in this case, I think, is a role concept. So we want a role domain type. But we don't want that to be backed by a node. We actually want it to be backed by a relationship. And so let's take a step back. We've talked about one main abstraction, which is node entity. Turns out that there are actually 2 types of entities. There's the node entity, which you know by now is it's a podio backed by a node in the graph. If you have normal primitive fields, they're just going to be saved as properties. If you have node entity fields, they're going to be connected to one another through a relationship. But then there's also the relationship entity, which is a POJO, but it's backed by a relationship in the graph. And it can only support primitive types because you can't create a relationship starting from a relationship. But primitive types are supported fully in the same way as node entities. So in this case, we have a relationship entity called role, and it wraps the relationships between Brad and Fight Club here. Well, the relationship between Brad and Fight Club. If you want to access the starting node and the end node, you just declare them with the @start node, and they're going to be injected, and @end node. And then we have a field called role, and that's a string, so it's just going to be serialized to the relationship. Pretty straightforward. Okay, so we've talked only about the programming model, but I should tell you a little bit about how to set it up. And it's very straightforward. It's the way you would expect in Spring. You add a simple namespace in your application.xml. You see the URIs on the screen here. I chose to call it data graph here in this example. And then you use the config element to initialize Spring Data Graph. In this case, I pass in a store directory to point it to a location on disk where I want to store my database files. Okay, we talked about repositories, and if you recall, we added an @indexed annotation to actor, to the name of the actor. The way repositories works is that there is a graph repository that takes a type, and a convenient way of working with it is that you extend it with your own interface. In this case, we have an actor repository that extends graph repository of the type actor. You want to, in order to get repository support, you want to configure the repositories to point to the base package where the repositories reside. And this, it's com example repo in this case. After that, super simple. You auto-wire in your actor repository, and then you can do find by property value. Look for any actor which has a name Brad Pitt, which I guess in my example so far will give you 0, because I think we set the name to Brad in this example. But you can also do prefix by using the find all by query method. In this case, we say, give me all the actors that have a name starting with ed star. So Ed and Edward and whatnot. We can do range queries. Find me all the actors that have an age property, which is a number, between 0 and 25. We can use find by ID, which is called find one, and you pass in the node ID. We can do simple and brute force things like give me all the actors, as well as just simple count. How many actors do I have in the database right now? We also support full text queries and many other things that you can look into the documentation tutorial to find out more about. I alluded to this a couple of times before. I've actually been slightly modifying the truth as we went along for pedagogical reasons only. No animals were hurt during the making of this webinar. But it turns out that when you create a new entity, it is actually not automatically saved in the graph. What you need to do is you need to first invoke a persist method to attach it to the graph. And this is based on feedback that we got from our first users, where there was a little bit too much magic going on. If you just created an actor and all of a sudden it got tied to persistence and nodes in here and there and transactions and back and forth. And sometimes you don't want that. You want to be able to pass it up to your web layer. You want to run it in unit tests in particular. So that's why we introduced the persist method. It's pretty straightforward. You can look more into the semantics in the documentation. One of the things that you want to be thinking about is that if you modify an entity outside of a transaction, I don't think this is usually a problem in Spring because you go at transactional most of the time, right? But if you pass it out of a transaction or boundary and start modifying it, you will need to invoke persist in order to flush, quote unquote, your changes down to the graph.